There are a lot of rules when it comes to circles, so we're just going to jump right in and get started. So tangent line rules. If a line is tangent to a circle, then it's also going to be perpendicular to the radius. So DC is a tangent segment, and if I were to connect A to D together, which is the radius, that with the tangent creates a 90-degree angle. So that's one of the rules that you would need to know for tangent lines. The second rule for tangent lines is if you have two segments that are tangent to a circle from the same external point, then the segments are congruent. So what that means is that if I have a tangent segment or line intersecting another tangent segment or line at the same point external to the circle, then that means that those are congruent tangents. So let's get started. We are given that BD is tangent to the radius, so that means that tangent line creates a 90-degree angle with the radius. Therefore, this triangle here is a right triangle. And we want to find x. Well, my radius AB is 5 centimeters, so I can label AE as 5 centimeters, which would mean that AD is x plus 5 centimeters. I can use the Pythagorean theorem since this is a right triangle. So I have a 5 squared plus a 12 squared is equal to an x plus 5 squared. A 5 squared is a 25. A 12 squared is a 144. And it's very important to know that an x plus 5 squared is not just an x squared plus 25. An x plus 5 squared, we do need a FOIL. So in my next step, I'm going to combine the 25 plus the 144. And now I'm going to FOIL this out. An x times an x is an x squared. An x times a 5 is a 5x. And then a 5 times an x is a 5x. So a 5x plus a 5x is a 10x. And then a 5 times a 5 is a 25. We are dealing with a quadratic equation, so we do need to set this equal to 0. So I'm going to subtract that 169 over. Now looking at the box method, I need two numbers when multiplied together equal negative 144, but when added together equal 10. So that's going to be an 18 and a negative 8. So I have an x plus 18 times an x minus 8 is equal to 0. And if I were to set both those equal to 0, I'd get x is negative 18 and 8, which x is a side length, so it cannot be negative 18. So x must be 8, which is the same thing as ED. ED, which was what we were trying to find, is 8 centimeters. Now my next one asks, is line M a tangent line? So what we're going to do is we're going to use the converse of the Pythagorean theorem to see if this is a right triangle. So your A is your smaller side, B is your middle side, C is your largest side. So if I do A squared plus B squared, does that equal C squared? So I have a 9 plus a 16. Does that equal a 36? 9 plus a 16 is a 25. So it does not equal 36. So no, by the converse of the Pythagorean theorem, this is not a right triangle, so the line cannot be tangent. Because remember, in order for a line to be tangent, it would create a right angle with the radius. All right, so looking at the next one, just looking at the diagram, I have tangent segment BC and DC intersecting at D or at C, so both of those are congruent. I have BA and FA intersecting both at the same point on the outside, so both of those are congruent. And I have tangent segment DE and FE intersecting at the same angle, angle E or vertex, so those are congruent. Now I know AC is 12. And I know CE is 20. And I know FE is 13. And I want to determine what AF is. So I'm going to label AF X. If AF is labeled X, that means AB would need to be labeled X. And if AB is labeled X and AC is 12, then BC should be labeled 12 minus X. And so since BC and CD are congruent, CD is also going to be labeled as 12 minus X. And since CD is 12 minus X and CE is 20, if I do 20 minus that 12 minus X, and I need to put that 12 minus X in parentheses, distributing the minus in, 20 minus a 12 is an 8. I get DE can be labeled as 8 plus X. If DE is labeled as 8 plus X, then EF should be labeled as 8 plus X. And so now, if I'm trying to find AF, which is X, if I take X and I add it to 8 plus X, that would give me my whole length AE, which is 13. Oops. And sorry, on yours it does say AE, mine says FE. Okay, so now I'm combining like terms. I have a 2x plus an 8 is equal to a 13. A 13 minus an 8 is a 5. So then x comes out to be a 2.5. So that means that AF is 2.5. Okay, so looking at my next one, I want to find a couple of things here. These lines are tangent, AB and AC, and they're intersecting at the same exact point on the outside of the circle. So this triangle here is actually an isosceles triangle. In isosceles triangles, the base angles are congruent. So if I do 180 minus 30 divided by 2, I get that these angles are 75 degrees. Well, also, a radius and a tangent create a 90-degree angle. So these are 90-degree angle here, and 90 degrees minus 75 degrees leaves us with these little angles being 15 degrees, which makes this blue triangle an isosceles triangle because the base angles are congruent. So if I do 180 minus 15 minus another 15, I wind up with angle D here being 150 degrees. So it does say to find the measure of angle A, B, C. We did that. That was 75 degrees. And then the measure of angle B, D, C. We found that. That was 150 degrees. All right, moving on. The next one, we have tangent lines intersecting at the external point. So they are congruent, which means I can set them equal to one another. Since this is a quadratic, I'm going to need to set it equal to 0. Subtracting the 2x over, my 2x's go away. And then subtracting the 5 over, I get a minus 12. So actually, since we lost that middle term of that 2x, I can actually just solve this using the square root method. So I'm going to add this 12 over here. I'm going to divide by 3. And I wind up with an x squared is equal to 4. And then I'm going to take the square root of both sides. And x comes out to be a positive or negative 2. Which, if I were to put positive or negative 2 back in, it actually works out for both segments. Both segments end up being positive for either positive or negative 2, so both of these answers work. All right, number 13, we're given BC is tangent, so that means the radius and the tangent create this 90-degree angle, and we want to find the radius. I'm going to label my radius as x, which means this is also x. So I'm going to take my x squared plus my 16 squared, and that would equal this squared. So that's an x plus 8. So I have an x squared plus a 256. And remember, an x plus 8 squared needs to be FOILed. An x times an x is an x squared. An x times an 8 is an 8x, and an 8 times an x is another 8x. So that gives you a 16x. And then an 8 times an 8 is a 64. Subtracting x squared from both sides, my x squareds go away. Taking that 256 and subtracting 64 from it, I wind up with a 192 is equal to a 16x. And then dividing by 16 on both sides, I wind up with x is 12, which was my radius, because I labeled my radius as x. So I found my radius. All right. XY is tangent to both circle O and P. We are given that OP is 40. And the radii of both circle O and P are 31 and 7 respectively. So that means O to X, which creates a 90-degree angle because the radius is perpendicular to a tangent. That is 31. And P to Y, this is not drawn to scale, is 7. So what we're going to do, we want to find XY. I'm going to label that as X. We are going to create an auxiliary line. And this auxiliary line is going to be parallel to line XY. So that way, these are 90-degree angles, and then this is a 90-degree angle here. And we are actually going to pick this one up in the next video.